Hey guys, Phil here, hope you're all well. What you're looking at in front of you is my Duratool ZD-915. Now these come in other brands, but they're generally the same. Internal, it's just they get rebadged. And what I want to do today is do some mods. So if you stick around, I'll crack on with that. So what I want to do now is talk about the mods I'm going to install into this desoldering station. Now the first one is a bit of an upgrade. You can see it here. This is a DC to DC converter. It's a mini switch mode power supply, and this is going to power the pump motor with 12 volts. And the second thing I want to install is a new fan. The reason for that is because the old fan is run at 18 volts when it should be run at 12 volts, and obviously with this thing being at 12 volts, this silent fan will run a lot quieter instead of the jet engine that's in this desoldering station. So yeah, they're the mods I'm going to be adding to this desoldering station. What I want to do now is quickly do a before, and you'll see how loud the fan is in this. And the reason, like I said, is because they're running at 18 volts when it's a 12 volt fan. So what I'm going to do is power on, and you'll hear how loud the fan is in this. And yeah, that really does sound like a jet engine. It's really loud, and it shouldn't really be that loud, but hopefully this mod will take care of that. Now you can probably hear the desoldering station in the background making that loud jet noise. What I need to do is I need to prep this board, and I need to remove these two connectors just here. So I'm going to take my desoldering gun and I'm just going to suck off the connectors. Hopefully they come off now. There we go, that's that one off. And this one's been a little bit stubborn because there's still some solder in that hole. There you go. That should have got that. Come on, and there we go. That's that one removed. What I want to do now is solder on the JST connectors. What I'll do is I'll put a link in the description below to everything you see in this video, including the JST connector set. These are 0.1 inch JST connectors. So I'm just going to wire those straight into this board. So this side is the input, so this will be the 18 volt input from the desoldering station. There we go. That's that connector soldered in. What I want to do now is solder in the output to the pump motor. So this is the pump motor. Now I'm going to go here, there on the two upper connectors, and of course it doesn't want to stay in because, you know, it's on camera. So I'll do one at a time. move that out of the way a little bit. There we go. Solder this one in. There we go, that's that negative lead soldered in. Now do the positive lead. Typical. There you go. Solder that in, leave it a second, let the solder flow through. And as you can see, that's the power for the pump motor, and the next one is for the fan that I'm going to install. So that goes in there. And what I'm going to do is I'm going to bend this wire over. There you go. It's a positive. Now for the negative. If you can hear a whirring in the background, guys, that's my dryer. It's pretty rainy today in the UK, so I've got the dryer going. Bend that over, solder that one in. Give it a second, and there we go. And that's the mini Switch-Mode power supply, all wired. What I want to do now is set this up for a 12 volt output, and as you can see it's already 16.5 on the output, so I need to change it to 12 volts, but I'll show you what the input is. You can see the input is 18 volts. Now the input that powers this is 18 volts, so obviously I need to get it down to 12. So to do that, I'm going to look at the output and I'm going to turn this variable resistor down, get it in the old, I need to get it down to 12 volts. Yeah, there we go. Nuts on 12 volts. Now if we look at the input, 17.9, basically 18 volts, and the output is 12 volts. So that's all set. It's ready to go into the desoldering station now. So it's time to get into this desoldering station. Now I'm going to warn you in advance, guys, there is a power supply in here and it's at mains voltage. So if you're going to do this at your own risk. I'm not responsible if you electrocute yourself. But yeah, I need to get into this thing. And there's screws on the top here, there's two on this side, and then there's two on the opposite side. I take those off and then I can get inside this thing. Okay guys, as you can see, I'm inside the desoldering station, and again guys, I want to be perfectly clear here. This is a power supply and there is mains going to this. You can see the mains cord there at the back. So if you're going to do this, do it at your own risk. I'm not liable for you electrocuting yourself. What I want to do now is I want to see what voltage the motor's at. So I'm going to take my desoldering gun and I'm going to pull the trigger, and it's going to get loud guys, but I just want to see what the voltage is of the motor. And there you saw it, it was round about 12 volts. So yeah, I'm gonna switch this thing off now. I'm gonna take out the mains cord and let it fall on the floor just to be safe. And what I'm gonna do, this is a great tip guys, power on, and what that will do is it will drain any residual energy in the power supply. So what I'm going to do now is, the first mod I'm going to do is take the old 50mm fan out, and I'm going to put the new fan in. So that's the first thing I'm going to do, and I'll be back in a second when I've done it. That's the old fan removed. It's time to put the new Fractal design silent fan in there. So I'll go ahead and do that and then come back. That's the new fan installed. What I need to do next is take this box out. Now this has two 5-watt resistors in there, and it takes this connection here, which is 18 volts, and it drops it down to 12 volts for the pump motor, but obviously that's not very efficient. And it also supplies the fan as well, but the crazy thing about that is it supplies the full 18 volts to the fan, and it's a 12-volt fan, so they're 50% overclocking the fan. So yeah, that new power supply, what that's going to do is obviously take this 18 volts and it's going to supply the motor with 12 volts and the fan with 12 volts. And obviously with this fan being a nice quiet one, it'll be super quiet. So yeah, I'm going to take out this box with those two 5-watt resistors. So that's that box removed, and if you take a look, so this connector here is the 18 volts in, and then obviously that gets down to 12 volts. So here's the connector for the motor. Obviously it's switched, so when you pull the trigger, that's when the motor comes on. And here's the new connector for the actual fan. So yeah, what I'm going to do now is I'm going to get that mini Switch-Mode power supply put into this thing, and then I'll come back. So this mini Switch-Mode power supply is ready to go in. You can see what I did is I've created a mount for it, so it can fit where the old box was. So yeah, I'm gonna release the STL files for this mount, so if you want to print this thing off, you can do. Like I said, I'll put a link to everything in this video. So yeah, let's get this mini Switch-Mode power supply put into the desoldering station. What I want to do now is talk about the way this was wired. And the reason I say that is you've got to be very careful when you're working on devices like this, because you can't assume things are what they are, right? And a good example of this is the way this device has been wired, and I'm going to show you that now. Now here's our main input, right? The 18 volts, that's going to feed the mini Switch-Mode power supply. Now this is what I mean where you shouldn't assume. Here you should always measure and make sure, because if we take a look here at the main 18 volt input, the main input color code is the black wire is the positive and the white wire is the negative. Now that's very unconventional when you're designing something. You generally don't do that. In fact, if I was designing that and I had to use two colors, obviously I use black and red. But if you not really using red, you would probably swap these round, so the black wire would be the negative and the white wire would be the positive. But you can see in this, it's the opposite way around, and this is what I mean by you shouldn't assume something. You should always measure and make sure, because what would happen is you would put your multimeter across these two wires and you would see a negative voltage come up, and that would tell you that the white wire is actually the negative and the black wire is the positive. So that's a great tip, guys. Never assume something is what it is. Always make sure, you know, the mother of all f-ups is assumption. That's from, I think that's Under Siege 2, if I'm right. I'm pretty sure that is. The mother of all f-ups is assumption.
Did you see the body?
I assumed he was dead.
Assumption is the mother of all f-ups.
Now that's not the only thing that's strange here. We take a look at the trigger for the pump motor. That's also flipped as well. So on mine there were two wires. They both had blue markings. One had a plus marking and one had a negative marking, and yet you guessed it, they were flipped the wrong way. The negative was actually the positive and the positive was actually the negative. So there you go again. Never assume something is what it is. Always measure. Now the fan was wired in okay. From the factory that was perfectly fine. But yeah, they've used, what's the word I'm looking for? Unconventional wiring is a good way to put this. They've used the black wire as the positive and the white wire as the negative, where if you was really going to do that, you'd swap them round and have the white wire as the positive and the black wire as a negative. And here they got this flip round as well. So yeah, never assume something, guys. So I've got the mini switch mode power supply installed. I've got the 18 volts going into it. I've got the switched pump motor power, and I've got the fan connector connected. So let's power this thing on and do a smoke test. And nothing's blown up. And you can see, if you look at the output on that, you can see it's 12 volts. Let's give it a quick test of the motor to see if that's working. Yep, that motor is working. What I'm going to do now, guys, is I'm going to set up my multimeter and I'm going to measure that motor just to make sure that it's running at 12 volts. I've got my multimeter connected up. I've got my leads across the motor. Let's see what voltage it is. I pull the trigger. That's about 11 volts, guys. So what I'm going to do is I'm just going to adjust this variable resistor until I get 12 volts on the motor. I'll do that off camera and then come back. And I've got that motor pretty much nuts on 12 volts. So if I pull the trigger now, you'll see that. And there we go. You don't get any more nuts on than that. Now you can see it's gone up by a volt on the mini switch mode power supply. Instead of 12 volts, it's now 13 volts. So there must be 1 volt drop. But yeah, that's that modded. What I'm going to do now is obviously power off. I'm going to take out the power cord and I'm going to do some cable management. And when I've done that, I'll come back. And there we go. Everything is nicely cable managed. Now the great thing about using JST connectors is I've not had to do any wire cutting and soldering. All I had to do was obviously solder the wires to the actual mini switch mode power supply. So the great thing about that is if I ever want to reverse this mod, all I have to do is to obviously take this fan out, put the old fan back in and the old box back in there, and it's back to factory. So yeah, what I'm going to do now is get this all back together and we'll give it a test. And we're all back together. what I want to do now is do a sound test just to see what it's like now. So I'm going to power on. And hopefully you can agree, that's a lot quieter now. What I want to do now is talk about a downside to this mod, because there is a downside to this mod, and that downside is something called inrush current, and I'll explain inrush current in a second. But first, what I want to do is, I've actually been using this mod for well over a month now. I'll show you the videos I originally shot. They were dated the 1st of October. It is now the 12th of November. And the reason why is I wanted to give this a really good test before I say, you know what, go out and do this mod. It's fantastic and all that. You know, I really wanted to make sure this thing worked and worked okay. So let me get on to inrush current. Now, one of the problems with motors like this is when you initially start them up, you get a massive spike of current rushing in, and that's called inrush current. And that's generally to kickstart the motor to start. But as the motor starts to run, it then dips down into what's known as steady current, and that's what the motor will generally run at when it's free running, basically. But initially you get a massive spike, and that's called inrush current, and that can be up to 20 times the actual steady current that the motor is pulling, which is absolutely insane if you think about it. But what you've got to remember is it's not a constant, it's just an initial brief hit for the motor. But that can cause problems with the motor, and it can also cause problems with the actual supply that is supplying the motor. Excessive inrush current can damage the motor, but it can also damage the power supply. Now, what we've basically done is we've taken away current limiting from this motor. Now, if you remember, there was a little black box with 2 power resistors in there, and what those resistors are responsible for doing is taking the 18 volts and dropping it down to 12 volts for the motor. But they'll also have an added benefit of restricting the inrush current that the motor is going to pull when it initially starts. But as you've seen, we've removed that from the circuit, so now there's nothing protecting that motor. Now, like I said, that can be detrimental to the motor and the power supply that is actually supplying the motor. And it's the reason why I've left this for a month, because I wanted to be 100% sure this thing was fine. I didn't want to just do the mod, say, oh, it's fantastic, go ahead and do it, it's brilliant, it's the best thing since sliced bread, right? I wanted to actually test it, and I've been testing it for a month, and I can honestly say mine, I don't know about yours, I don't know what the situation will be with yours, but mine this month has been absolutely fine. I've not seen any signs of distress from the motor. The way you look for signs of distress from the motor is changes in its pattern. So does it slow down? Does it speed up? Does it make a funny noise? I've not seen any of that. It's been absolutely fine. And obviously the actual power supply in there has been fine, that's been feeding the motor. But like I mentioned, there is a downside to this, and that's that inrush current. And yeah, I wanted to just make sure that this thing is working perfectly fine before I give it the thumbs up and say, yeah, I'm happy. You just need to be aware that you're removing that current limiting, and that limits the inrush current, and you know, you're taking that away from the motor, and that can affect the actual motor itself and the power supply. But as it stands, touch wood, this thing has been perfectly fine. What I want to talk to you about now is the benefits I've seen. We've talked about one of the cons, which is obviously the inrush current, but I want to talk to you about the benefits. Now, the first benefit is this thing is a lot quieter. I can sit here and record with this as you see it now, and I'm not shouting over the top of the fan to try and get you to obviously understand what I'm saying. Now, it's not completely silent. I'll turn it on and you'll hear it. Now, obviously, that's not completely silent, but you may notice I'm not shouting over the top of it anymore. So I'll just turn that off. So that's a massive benefit. Obviously, you're still going to get the sound of the gun when you evacuate the solder. That's just, you know. Also, you're not going to completely silence this thing. The reason for that is you've got to remember what it is. It's a fan in a metal box. So you're going to get resonance, right? And you're going to get that sound coming out. One thing that really angered me was, you'll probably know I'm a big fan of Noctua fans. And I wanted to put a Noctua fan in this thing, but I found out Noctua don't make 50mm fans, which, if you ask me, is bizarre, because 50mm is a very standard fan. And for Noctua not to make those fans is just bonkers, if you ask me. But yeah, I got another one that was quite a Fractal one that is quieter. So the most, in my opinion, benefit to doing this mod, I would say this thing sucks harder, right? This thing evacuates the hole a lot quicker, and it's probably down to we've removed that current limiting from the motor, so that motor gets turned on really quick, and because of that, it can suck the solder a lot quicker. And that leads on to another benefit of that as well, because this thing is sucking the solder through a lot quicker. It doesn't have time to solidify in the tube, so I'm spending less time cleaning and unblocking this thing. And I can give you the perfect example of that. The other day I had to do a Neo Geo AES. A friend of mine got a Neo Geo and he wanted me to put the UniBIOS in there, and I was like, yeah, not a problem, I can do that. And I had to suck out the old BIOS chip that was in there. Now that's a 40-pin chip, and generally when you're using one of these, you may have to clean it one, maybe 2 times before you get the chip out, because obviously it gets blocked and you have to clean it out every now and again. And on a 40-pin chip, you're probably doing that once, maybe twice. This thing blew through the whole chip in one go. I didn't clean it out once. It was absolutely phenomenal. It was just zzz, 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 and it was just evacuating those through holes like it was no tomorrow. It was absolutely phenomenal. So yeah, free benefits straight away. This thing's a lot quieter. This thing sucks harder. It evacuates the hole a lot quicker, and because it does that, it doesn't have time to solidify in the tube here, and I'm not unblocking it as often as I was. So yeah, they're the 3 benefits that I've noticed by doing this mod. What I've done off camera is I've set up a little test for the desoldering station. I've soldered a chip to some Vero board, and I've made it double tricky because I put some solder bridges in there, you can see that. And what I'm going to do now is see if this thing can suck this chip off. So let's give it a test. I could steady my hand a bit better. And this is where it helps having asbestos fingers. And that should come off now. Yeah, look at that. Easy peasy, lemon squeezy. So yeah, there you go guys. One nicely quiet and sucking a lot better, ladies, desoldering station. So yeah, there you go. Hope you liked the video. If you did, please give it a big thumbs up, like, comment, subscribe, all the usual stuff. And as always, I'll catch you on the next one. Winner, winner. Look how quiet it is now. Catch you next time, guys.